Hi, welcome. Today I would like to share with you Shunt Stub matching network using Smith chart. This is a transmission line mismatch between Z0 and ZL. So what we have to do to match the network is using stub. The main idea of shunt stub matching network is to find length of D and L in order to get YD and YL. The second is to ensure total admittance Y total is equals to YD plus YL, which is equals to 1 for complete matching network. Step of shunt stub matching network. Locate the normalized load impedance ZL prime. Draw constant VSWR, circle and locate YL. Move clockwise wavelength toward generator along VSWR circle to intersect with 1 plus minus JB, which is the value of YD. The length moved from YL towards YD is the true line length D. Locate YL at the point plus minus JB. Depends on the shorted or open stub. Move along the periphery of chart towards YL, wavelength towards generator. And lastly, the distance traveled is the length of stub L. Let's do a simple exercise of single shunt stub matching network. Given a mismatched transmission line consists of ZL is equals to 60 plus J 80 ohm and Z0 is equals to 50 ohm. So in order to match our network, then we have to add a single shunt stub at our system. So what we have to do is to calculate what is the suitable distance from load to our stub and what is the length suitable for the system. Okay, so first step that you need to do is plot normalize impedance. Okay, that is our ZL prime. So ZL prime is equals to ZL divided by Z0. ZL is 60 plus J80 and divided by 50 and you will get 1.2 plus J 1.6. So we're going to plot 1.2 plus J 1.6 at our Smith. So we're going to go to our second step, which is draw VSWR circle. Okay, so once we have drawn our VSWR circle, then we will draw a line, from Z0 to ZL prime and automatically we will find our YL prime. Okay, so I will do a bit of calculation first. Okay, YL prime is 1 over ZL prime. Okay, so 1 over ZL prime kita, which is 1.2 plus J 1.6. Okay, you will get around 0.3 minus J 0.4. So we want to see whether when we plot our YL prime, do we get the same as 0.3 minus J 0.4. Okay, so this is our Smith chart. So I will plot our ZL prime. Okay, so our ZL prime that we have calculated just now is 1.2 plus J 1.6. So if you can see here, this is 1.2 at real part, and for imaginary part is 1.6. Since it is positive, so it will be on the upper side. So this is 1.6. Okay, 1.6 and 1.2. So this will be our ZL prime. Okay, so again 1.6 and 1.2 2 at here. So this is will be our ZL prime. Okay, so what you want to do is to draw VSWR circle from Z0 to ZL prime. Okay, use your compass, put it at our Z0, which is our 1.0, and our another end of the compass is plot at the ZL, and then draw a VSWR circle. Okay, so VSWR circle that will be there. Okay, and then you will draw a straight line from Z0 to ZL prime. Okay, be here. I will zoom out a bit. Okay, and then I will extend this ruler to the other side in order for me to find my YL prime. Okay, so it will be like this. Then draw a straight line from the bottom to the upper side. Okay, straight line. Okay, once you have satisfied, okay, this is your straight line. So this is our ZL prime, and YL prime is 1 over ZL, which is 180 degree from our ZL. So it is here. Okay, this is our ZL, YL prime. Okay, YL prime. So if you can see the reading of YL prime, it is here 0.3 real part, and our imaginary part is minus 0.4 because it's in the lower side of the circle, so it's 0.4. So as you can see, it's same as our calculation value, 0.3 minus j 0.4. So you are on the right track. Okay, so next step, what you want to do is to rotate YL prime to the nearest intersection of VSWR and match real part. Okay, match real part is the 1.0 circle. So let me highlight this for you. Okay, 1.0 circle. So this one is our 1.0 circle. Okay, I will zoom in a bit for you to see more clearer. Okay, this is 1.0. So I will move along to the lower side. Okay, there are 2 points if you notice. Um, the intersection of VSWR circle and the material part, which is we have one at the top and one at the bottom. So what we have to do is we have to move YL prime, okay, towards generator. So we're gonna use the outer scale towards the generator to the first intersection of VSWR and material point. So in this case, YL is here. So we're going to move, okay, clockwise and to the first intersection. This is our first intersection. So first I will draw a line of our intersection. Okay, intersection S is will be right here. Okay, so label that as let me change color. Okay, I will label that as YD. Okay, YD. So this is our YD here, the first intersection. So use our ruler. Okay, from the Z naught. Okay, take it until our YD. Okay, so straight line. Okay, next is we want to know what is the um, distance. Okay, what is the distance? YL, the location of YL prime. Okay, we will read at the wavelength towards generator, so it is the outermost. Okay, so here is 0.43, this is 0.44. So okay, so it's around 0.43246. I'll take it as a 6. So 0, sorry, okay, 0.436 lambda. Okay, and then from 0.436 lambda, okay, the direction is moving from here up until our far end, which is here. This is 0, so one whole turn is a 0.5 lambda. Okay, and then it will start back from 0 and we will move until we find the YD. So YD is here 0.17, 0.18. So I will take it as 0.0174 lambda. Okay, so after we reach the maximum point and then we will go around until we reach 0.174 lambda. So the red point is your D, the length of your D. Okay, so we write down, okay, step number 3. Okay, so step number 3 is to rotate YL prime towards generator to match real part. Okay, so we take the first intersection of match real part and VSW R circle. Okay, so YL prime is at, so look back at our Smith chart. Okay, YL is at 0.436 lambda. Okay, so YL is at 0.436 lambda and YD is at 0.174 lambda. Okay, 0.174 lambda. So the distance from YL prime to YD is 0.5 minus 0.436, okay, lambda, and then you plus 0.174 lambda. Okay, so 0.5 minus 0.436 plus 0.174, so you will get 0.238 lambda. Okay, so this is the distance where you want to place our stub, shunt stub is 0.236 lambda from our Z loop. Okay, next is we want to calculate what is the length of our stub. Okay, so in order to calculate the length our stub is to um, identify where is our YL. Okay, so from the slide, okay, we know that, okay, point 4, okay, Y total is equals to yd plus yl, which is equals to 1. Okay, so yd, okay, let us look where is our yd. Okay, okay, location of our yd is here. Okay, so yd is 1.0 plus a slide of 1.4. Okay, so I will take it as 1.4 1.42. Okay, so yd is 1 plus 1.42. Okay, so yd is 1 plus j 1.42 plus yl is equals to 1. So yl is equals to 1 minus 1 plus j 1.42. So that will leave us with 0 minus j 1.42. Okay, so we must plot yl, which is 0 minus j 1.42. Okay, so 0 for real part is our the largest or the outer part of our circle. So this will be our 0, and since it is minus, so it will be at the lower side. Okay, so minus j 1.42. Okay, zoom in. So this is 1.4, so 1.42 is somewhere here. So next is we're going to draw a straight line just like we do at our YD. So I will take a blue color. Okay, draw a straight line from the Z naught or our center and to our YL. Okay, I will let me draw a straight line first from here. Okay, all right, so let me label first for you. So this will be our YL. Okay, 0 minus J 1.42. So this is our YL. So we're going to use the same scale, which is wavelength towards generator. So we're going to use the outer. Okay, moving here. Okay, so at the outermost, our YL is at, this is 0.34, this one is 0.35, so I can say it is around 0.348 lambda. Okay, 0.348 lambda. Come back here. Okay, so step number 5. Okay, so step number 5, we're going to um, YL, we're going to rotate. Okay, we're going to rotate YL towards generator 2. Okay, so single shunt stub, we're going to use an short circuit stub. Okay, we're going to use a short circuit stub. So we're going to rotate YL towards generator 2 Y short circuit. Okay, so for admittance, okay, this is our Smith chart. Okay, this is our real part. Okay, the furthest towards the left is our open circuit, and furthest point of our right place is our short circuit. Okay, so for open circuit it can be 0 or 0.5, and for short circuit is 0.25. Okay, looking back at our Smith chart. Okay, so our short circuit is here. 0.25. Okay, so label here, this is Y short circuit. Okay, so we're going to rotate. Okay, we're going to rotate towards generator. So towards generator, okay, so it's from Y short circuit towards YL. Okay, towards generator, so towards YL. So this is the value of L. Okay, okay, so YL is at 0.348 lambda, and Y short circuit is at 0.25 lambda. So in order to calculate L, okay, so L is equals to from 0.25 to 0.348. So 0.348 is larger than 0.25. So we take 0.348 lambda minus 0.25 lambda. So you will get 0.098 lambda. Okay, so the length of our stub is gonna be 0.098 lambda. Okay, and the distance from load and the stub is 0.238 lambda. Okay, so I hope you can understand my teaching on single shunt stub matching network. Thank you.